Hey guys, I just wanted to go over your Unit 1 exam review trig applications. So, problem number 1 says, give a pair of angles that are coterminal. Okay, so you should remember coterminal angles are angles that fall at the same spot on your unit circle. So if this was our unit circle, and let's say we were looking at 30 degrees. Well, what's another angle that falls right here on the circle at 30 degrees? Well, if I go around the circle one time, I could say 390, because I added 360 degrees. So I could say that 30 degrees and 390 degrees are coterminal. Oh, that's supposed to be a degree. Are coterminal because there's 360 degrees between them. Alright, number 2. Find the length of an arc of a circle radius 100 centimeters if the arc subtends a central angle of 5 radians. Okay, so length of arc, that means I want to find S equals, okay, so then I think, okay, is my angle in degrees or radians? It's in radians. So to find an arc length in radians, I say S equals theta R, okay? And I want to find S, so I don't know S, so I leave S as S, is equal to theta, which they tell me is 5, times the radius, which they tell me is 100, and so I can say 5 times 100 is 500. So S is equal to 500 centimeters. Okay, there I go. That's your arc length. Alright, let's try problem number 3. Problem number 3 says, find the radius of a circle if an arc length 20 meters is subtended by an arc measuring 115 degrees. So first off, I want to find R. I know an arc length, so I know an S. Since I know an S, I'm going to be using an S equals formula. Now, I'm not going to be solving for S because they already told me what S is, but I'm still going to be using an S equals formula. And then they tell me the angle is 115 degrees. Since it's degrees, I want to use the theta over 360 times 2 pi r formula. Okay, now I know what S is. S is 20, so I say 20 is equal to theta, which is 115, over 360 times 2 pi, and then r. I don't know what r is. Okay, so now I need to solve for r. And you might remember that when we did this before, I take these three, and what I like to do is anytime I'm trying to solve for a variable that has a bunch of stuff multiplying together in front of it, I just multiply all this stuff together first, and then I can just divide both sides by this big number that I'm going to get, okay? So we pull up our handy-dandy calculator. And we turn it on. Any day now. Any day. So we say 115 divided by 360 times 2 times pi. Okay, and that's going to give me this number, 2.00712.864. So that's all the number that's multiplying to r. So if it's multiplying to r, the opposite of multiplication is, that's right, division. So I'm going to divide both sides by this number I just got, and I get 9.96. So I can say that the radius is approximately 9.96. Alright, moving on to problem number 4. Oh, I need to erase this. Find the measure of a central angle theta measured in radians in a circle of radius 8 meters if the angle is subtended by an arc of length 48 meters. Okay, so first off, they want me to find theta in radians in a circle radius 8, so they give me r, if the angle is subtended by an arc of length 48. Since I know an arc length, I'm going to say S equals. It says do it in theta, it says theta measured in radians, so I need to use theta r. So S is equal to theta r. They tell me that S is 48, so I can say 48 is equal to theta times 8. So then, to get theta by itself, I divide both sides by 8. 48 divided by 8 is 6. So I get 6 is equal to theta. And wham bam, 6 radians to be specific. Very good. Okay, let's try to do number 5. Number 5 says, find the area of a sector of a circle with a radius 7 with a central angle 70 degrees. So first off, it says find the area of a sector. So that means I want to use A equals. Okay. A equals, and then it gives me the angle in degrees, so I need to use the formula theta over 360 degrees times pi r squared. Alright, and they want me to find A, so I'm going to say A equals again because I don't know what A is equal to 70 over 360 degrees times pi times 7 squared. And then I can just put all this side in a calculator, and you're going to put pi in, you're going to get in decimals because the angle is given to us in degrees. And when we get the angle in degrees, we can leave it in terms of, we can put it in pi into the calculator. We can get decimals. Okay? So we're going to say 70 divided by 360 times pi times 7 squared. And that gives me 29.93. So I can say that the area is approximately 29.93. Okay? Alright, let's move on. Oh, I said 7 inches. If I'd wanted to in the last problem, I could have said 29.93 inches squared. Alright? Number 6, change 25 degrees to radians. To change degrees to radians, I multiply the degrees by pi radian over 180 degrees. Okay, so the degrees cancel out, and 25 and 180 can both be reduced by 5. So let's see, 5 will go into that 5 times, 5 goes into 180, let's see, 5 goes, that's going to be 3, carry down the 3, 36 times. So you get 5 pi over 36 radians. Alright, let's try to do number 7. Now, number 7 is a tricky one because it says change 3 pi degrees to radians, okay? So 3 pi degrees is 3 pi degrees. Okay, so I went ahead and put my degree symbol there. Times, okay, how did I change degrees to radians a second ago? I multiply by pi radians over 180 degrees. So I'm allowed to cancel out the degrees. I'm allowed to cancel out the 3 and the 180. 180 becomes 60. Now, a lot of people make the mistake of canceling out these pi's. We can't do that because neither one of these pi's is in the denominator position. So in other words, you're going to say pi times pi. Well, since I'm getting it in terms of radians, I like to leave pi as pi. So pi times pi is pi squared radians all over 60. Alright? And that would be your answer for number 7. Let's try problem number 8. Problem number 8 says change pi over 7 radians to degrees. So now we're going the other way. So I want to say pi over 7 radians times 180 degrees over pi radian. Now, this time, since I have a pi both in the numerator and in the denominator, they can cancel out. So can the radians. So I end up with 180 degrees over 7. And I can just add that in my calculator because since we're going to be talking about degrees, I am allowed to get decimals. So I say 180 over 7, and I get 25.7 degrees. 25.7 degrees. And there you go. Okay, number 10, it says find sine theta. Excuse me. It says find sine theta and cosine theta when theta is equal to 60 degrees. Okay, so in this case, if I was you guys, I would just grab my handy-dandy trig chart, my unit circle that I've made that we spent time developing in class, and I would go to the 60 degree, and you know that sine is y and cosine is x. Okay? Now, let's say for some reason you don't have your trig chart. Well, here's another trick you could use. You could remember that you know that there's only 3 types of points all around the trig circle. Square root of 3 over 2, 1/2, and square root of 2 over 2. Now, sometimes they're negative, but you remember there's only those 3. And you remember that if you remember the square root of 2 over 2 is always square root of 2 over 2 in x and square root of 2 over 2 in y, then you know that the 1/2 and the square root of 3 over 2 have to go together. Okay? If you can remember that, then what you can do is you can grab your calculator and you can say, okay, I want to be in degree mode real fast because I'm going to plug it in. Degree, so I can quit. So you can say sine of 60. Okay? And that gives you some weird number. Alright, and then you can say cosine of 60. Okay, so since that got you 0.5, you probably know that 0.5 is the same thing as 1/2. So then you know that, I want to make those. So if cosine of 60 is 0.5, which is 1/2, then you know that the sine of 60 is probably square root of 3 over 2. And then the last thing you just have to simply think about for a quick second is, does 60 degrees make x or y negative? No, it's in quadrant 1. So x and y are both positive, so this is a perfect answer. Okay, moving on to problem number 11. Okay, number 11. A plane is flying at 30,000 feet and spots an airship off in the distance. The angle of depression from the plane to the airship is 42 degrees. What is the distance from the plane to the airship at that moment in time? Okay, so there are 2 ways to this problem. Actually, it's probably more than 2 ways, so I'm going to give you 2 ways. Okay? The first way is to recognize this is a right triangle. So the fact that it's a right triangle, I know I could use Pythagorean Theorem if I knew 2 sides. I don't, so I cannot use Pythagorean Theorem. But I could use SOHCAHTOA. Okay? The fact that it's a right triangle means I can use SOHCAHTOA, trig ratios. Okay? So I know 42 degrees. I want to find x right here. And I know the opposite. I want to find the hypotenuse. Which trig ratio deals with the opposite over hypotenuse? Sine does. So I can say sine of 42 is equal to 30,000 over x. Now, in order to get x by itself, since x is in the denominator, I have to first start off by multiplying both sides by x. Okay, so then I have x sine 42 is equal to 3,000. Okay, and then after that, I divide both sides by sine 42. Okay, so I divide both sides by sine of 42. Alright, so that cancels those out, and I get x is approximately, and I can grab my handy dandy calculator, and I can say, turn it on, 30,000 divided by sine of 42. I checked that it was in degree mode earlier on in this video, so it's still in degree mode. I press enter, and I get 44,834.3. 44,834.3. And bam, I'm done. All right. The distance from the plane to the ground is 44,834 feet. Okay, now, I'm sorry, distance from the plane to the airship. Sorry about that. Okay. Now, I said I would show you another way to solve this problem as well. When we were in class earlier, I saw a lot of you guys were setting up your T-chart with sides and angles. Okay, so in order to stay true, just kind of make sure you guys are aware you can use this. I want to show it to you, okay? You could call your triangle any format of ABC. Alright, and then you can say this is little a, this is little b, this is little c. Alright, so then you can say that little a is equal to, I don't know, little b is equal to 30k. I'm out of space, so I'm just going to say 30k here. This is 30,000. This is 30,000. Okay? And little c, I don't know. But that's what I actually want to find, so I'm going to put a question mark on it. And then big A is, I don't know, big B is 42, and big C is 90. So now, several of you I saw were saying, oh look, I have a pair, and I have half a pair, so therefore I can use law of sines. So I can say 30,000 over sine of the angle opposite 30,000, which is 42, is equal to C over sine 90. Okay, and then you can cross multiply, so you get 30,000 times sine 90, so I'm going to write that over here. 30,000 times sine 90, okay, is equal to C times sine 42. So then, if it's C times sine 42, in order to get C by itself, I'd have to divide both sides by sine of 42. So I divide that side by sine 42. I divide this side by sine of 42. Okay. So then, I'm going to get C by itself. So all this side just needs to go into a calculator. So I could type in 30,000 once again. 30 times sine 90 divided by sine 42. Press enter. And I get the same exact answer that I got earlier. Okay? So either one of these ways will work. I just want to show you both ways because I saw a lot of you guys in class doing it this way. but at the same time I wanted to show you the fact that it's a right triangle, I could still use my trig ratios. Okay, moving on. Number 12. A tire swing hangs 18 feet above water. A swimmer is 60 feet away from the swing. Alright, so this is a right triangle. He's 60 feet away from the swing. He is 18 feet above the water. What is the angle of elevation from the swimmer to this tire swing? So I want to find theta right here. Alright. So the fact that this is a right triangle, guys, really makes me want to approach this with right triangle trig. Okay, I would rather not try to do, Pythagorean Theorem to find the third side, and then use law of cosines. To me, that's a lot of work. Whereas if I just remember this is a right triangle, so I guess you could use law of sines again. To be fair, you could use law of sines again. You could say 60 over sine 90 is equal to sine theta over 18, but really, in this problem, I'm going to approach it from right triangle, trig. The fact that it's a right triangle, I can say this angle is equal to the opposite side divided by the hypotenuse. So I can say sine of theta, because sine is what deals with opposite over hypotenuse, is equal to 18 over 60. And then I can just take the inverse sine of that. So I can say theta is equal to sine inverse of 18 over 60. Okay, so I can then grab a calculator, and I can say second sine 18 divided by 60. Press enter, and I get 17.5. So the angle of elevation is approximately 17.5 degrees. Alright, moving on. Problem 13. How many points on the unit circle? Infinitely many. I know that on ours, we only talk about 16. Those are 16 specific ones. There are actually infinitely many. We just happen to only address 16 specific ones. Alright. So, moving on to 14, sorry. A communication satellite is above receiving towers A and B. It is determined from the radio signals that the angle of elevation of the satellite from tower A is 87, and the angle of elevation from tower B is 82. If A and B are 1130 apart, approximately how far is the satellite from tower B? So I want to find this line right here. Okay. So what I notice is that right now I want to find X, and I only know one angle inside this triangle. Well, there's a way you can find this angle. The fact that you know this is a line, I know that then the combination of these two angles must be 180 degrees. So then if this side is 87, then I know that this side has to be 180 minus 87, which is 93. Now, this is not a right triangle, so I cannot use Pythagorean Theorem. I cannot use right triangle trig. So instead, I'm going to set up my sides and angles table. So, and this is C, by the way. So they already told us that little a is what we want to find, so I'm just going to put that as X. Little b, I don't know. Little c is 1130. Big A is 93. Big B is 82. And big C, I don't know. But wait, I don't have a pair yet. Okay? But there's a way I can get this third angle real easily. Yes. You know that all triangles must add up to 180 degrees. So you know that if this is 93 and this is 82, I can add them together to get the missing angle from right here. So let's see, 93, that's 175, so this is 5 degrees. So this angle is 5. So now this is a law of sines problem. I can say X over sine of 93 is equal to 1130 over sine of 5. And then I can cross multiply. So that gives me X sine 5 is equal to 1130 sine 93. And then I can divide both sides by sine 5. And I'm going to get X by itself at that point in time. Okay, so that cancels out, and I get X is approximately, so now I just need to grab a calculator and check to make sure. So I can just simply say 1130 times sine 93, all divided by, and I suggest you guys use your alpha y equals enter, that fraction ability, just to make sure you're not making mistakes, but you get 12,947.5. 12,947.5. Okay. Okay, moving on to problem 15. Problem 15. Actually, we're going to skip problem 15 for a second and come back to it, okay? I'm not a big fan of problem 15, so we're going to skip it for a moment, and then we're going to come back to it, okay? Problem 16. If the base of the ladder is 8 feet from the building and the angle formed by the ladder on the ground is 71 degrees, then how high up does the building does the ladder touch? Okay, so it says the base of a ladder is 8 feet away. It's a right triangle. It says the angle formed by the ladder and the ground, so that's right here, is 71. So that's right there. How high up does the building ladder touch? So that's X right there. Guys, this is a right triangle. So I'm going to use right triangle trig. Okay? I'm going to say that opposite and adjacent, so I can say tangent of 71 degrees is equal to the opposite side divided by the adjacent side. So now I just need to finish solving for x. Well, to finish solving for x here, I just need to multiply both sides by 8. So I'm going to multiply both sides by 8, so I'm going to do 8 times tangent of 71. 8 times tangent of 71. Oops, I typed 74 there. Alright, and I get 23.2. So the ladder touches 23.2 feet up. So x approximately is 23.2 feet up. Alright, moving on to problem 17. Determine the side labeled x in the triangle below. Okay, so first off, I don't know if this is the right triangle, so I cannot use right triangle trig. I cannot use Pythagorean theorem, so that means I need to make my t-chart. So I say sides, and I say angles. Little a, little b, little c. Big A, big B, big C. So A, B, C. It's okay if you label it differently, just as long as you stay consistent. So little a would be 117. Little b would be 212. Little c is the side I'm trying to find. Big A, I'm sorry, I don't know. Big B, I don't know. Big C is 65. Okay, so I don't have any pair of opposites here. So I can't use right triangle trig. I cannot use Pythagorean theorem. I cannot use law of sines. So that means I'm down to trying law of cosines. I want to find a side. So to find the side, as long as you know the other two sides and the angle across the side you're trying to find, you can use the cosines. So you can say x squared, that's the side you're trying to find. You can say c squared too, it's not a big deal. Is equal to 117 squared plus 212 squared minus 2 times 117 times 212 times cosine of 65 degrees. Okay, so now I grab my handy dandy calculator. I say 117 squared plus 212 squared minus 2 times 117 times 212 times cosine of 65. I press enter, and I get 37,667. That's what the x squared is equal. That's what little c is equal to. C squared, sorry. That's what little c squared is equal to. So I need to square root this to actually get the correct side. I press answer, and I get 194.08. So x is approximately 194.08. All right. Okay, let's move on. 18, 19, and 20. Okay, these are three that you're going to have to memorize. I just want to see if you guys can memorize. I think that's an important skill. All right, what is the reciprocal of sine theta? That is cosecant theta, CSC theta. What is the reciprocal of cosine theta? That is secant theta. And we're going to talk about these and how to use them in depth later on, but we're just trying to see if you guys can actually still use your memorization ability. What is the reciprocal of cotangent theta? That is just tangent theta. All right, it is important that you memorize those. They will be on the test. Okay, last but not least, I said we go back to number 15. 15 is a very weird question, okay? So honestly, if I was you and I was studying for this test and there were other things that came more easily to me on 15, but maybe I still need to study them, I would ignore 15 until the very end, okay? 15 is a weird question. I don't entirely know why we're putting it on the test, actually, okay? But I don't control that. This is a district test, all right? So the first thing says find cosine theta plus tangent theta. Okay, This is a right triangle trig. Okay? It's a right triangle, so I can find the third side. Well, I don't know the angle, so I cannot use right triangle trig. Not yet. I'll tell you what I mean in just a second. But I can find this third side through Pythagorean Theorem. So that's the hypotenuse, so I can say the hypotenuse squared is equal to the other two sides squared and being added together. So 3 squared is 9, 5 squared is 25, so then I can say that the hypotenuse squared is equal to 34. I can square both sides, so I get that the hypotenuse is equal to the square root of 34. Okay, now it wants me to find cosine theta plus tangent theta. Well, what is cosine theta for a right triangle trig problem? Well, cosine theta is adjacent over hypotenuse. Okay, so then what's the adjacent side for theta? 5. What's the hypotenuse? Square root of 34. So I can say cosine of theta is equal to 5 over the square root of 34. Okay, but what's the problem with that? Well, I can't have a square root of 34 in the denominator. So I need to multiply top and bottom by square root of 34. And this gives me 5 square roots of 34 all over 34. Okay, so that's what cosine of theta is equal to. Now I need to do tangent of theta. Tangent of theta is equal to opposite over adjacent. Opposite is 3, adjacent is 5. So 3 over 5. Now I have both cosine, which is this, of theta, and tangent of theta, which is this. Now I need to add these together. So 5 square roots of 34 all over 34 plus 3/5. Okay, well the problem here is the fact that I do not have a common denominator, so I can't actually add them, but I can make them have a common denominator by saying, okay, 5 multiplied by 34 on top and 34 on bottom, because that's what the other denominator is, then multiply this one by 5 over 5. Okay, so then this numerator right here, this portion of the numerator, is going to become 25 square roots of 34 all over, let's see, 5 times 34, I'm not entirely sure what that is off the top of my head, 5 times 34, and I get 170. Okay, so 170 plus, alright, 3 times 34, once again, that's not something I know, it's just straight off the top of my head, so 3 times 34, 102. So I say plus 102, and then 5 times 34 I just checked. I know that's 170. Okay, so now that they have a common denominator, I can add them together. But here's the thing, I can't actually put these numerators together because they're not like terms. So, because the 25 has the square root of 34 attached to it. So literally all you can write as your answer is 25 square roots of 34 plus 102. I mean, if you want to write 102 plus 25 square roots of 34 in that order, that's fine too. All over 170. And that's really as far as it can go. That's as far as you can take this problem. It's just that. Okay? So that's a weird problem. And honestly, 15 would be the last problem I'm worried about on the test. I might just take that one at a loss, to be completely honest with you. Okay? It's a weird problem. I've shown you how to do it. Feel free to study it. But I'm just saying that I would concentrate on other problems before focusing on that one. Okay? Alright guys, I know this is a lengthy video. Alright, please send me an email, send me a reminder with any questions you have. I will try to answer them as soon as I can. Alright? Thanks.